Alright, so we got some practice problems here for you to do. My face is in the way. Let me see if I can get out of the way. There we go. Okay, so the demand equation for a certain commodity is P, that stands for price, equals 1/12 x squared minus 10x plus 300. And it says this equation works for when x is between 0 and 60. So, of course, it doesn't make sense to calculate the price for less than 0 items. But apparently the price function would be very different if we went above 60 items. So that might mean that that we have to hire more people or something along those lines. But it says find the value of x and the corresponding price that maximizes the revenue. So we're going to jump into revenue, which is price times quantity. So our price here was 1/12 x squared minus 10x plus 300. Now be times x. So that's our revenue equation. It's not in the form that we'd really like to take a derivative of, so let's work with it. Let's distribute that x through. So we'll have 1/12 x cubed minus 10x squared plus 300x. And now that would tell us the revenue for x items. So what we want to do is we want to figure out where that would have a high point. So we'll take the derivative. So 3 times 1/12 is 1/4 x squared minus 20x plus 300. We're going to set that equal to 0. So we'll have 1/4 x squared minus 20x plus 300. And it says find the value of x and the corresponding price. So I'm going to use quadratic formula to solve this. I don't think it's really necessary because I think it's going to give us nice answers. But let's see. It'll be x equals negative b, so that'll be 20 plus or minus the square root of 20 squared minus 4 times 1/4 for A, that's nice, times C, which is 300. And it'll be all over 2A, so 2 times 1/4. So I'm going to pause and work this out. You should do the same. But we'll get 2x answers out of this, we should. So let's just pause it and work through. So I got 2 answers. I got 20, x being 20. Come on, you can write. And x being 60. And both of those are between the 0 and 60 range, so we're okay. But let me point out a thing here. Our function was an x cubed, and it's a positive x cubed. So the positive x cubed graph is a cube that goes up. So it has 2 turning points. The first one you run into would be a high point, and the next one would be a low point. So the 20 comes before the 60, so that would be the high point, and the 60 would be a low point. So we can conclude that there would be find the value of x. So 20 items gives max revenue. It says find the corresponding price. So we could plug that 20 into the P. Price equals 1/12 20 squared, the P for the price up here, minus 10 times 20 plus 300. So that price will be, I'll have to use a calculator. Let's see here. I know the last part of this is 300 minus 200, so I'm going to be adding 100 to whatever I get. So I get 400 divided by 12 plus 100. So approximately, when I round off, this price that I want to sell things at to maximize my revenue will be $133.33-ish. So 20 items for the max revenue, and the price that makes that happen would be $133.33. And if I wanted to figure out the actual max revenue, I could just multiply those or bring that 20 back to my revenue equation. All right, let's see what's next. I know we got another problem down here. Let's see. Come on, you can move. There we go. Don't put my head in the way again. A swimming club offers memberships at a rate of $200 provided a minimum of 100 people join. So we're not going to do anything less than 100 people. For each member in excess of 100, the membership fee will be reduced by $1 per person for each member. At most, 160 memberships can be sold, so we can't just keep adding people to the list to get the price down to 0. So there is a cap on the number of people that can be there. So how many memberships should the club try to sell to maximize the revenue? Okay, so revenue, sometimes we think of it as, we're thinking of it as price times quantity. So revenue here of X will be, let's just set up two little price times quantity things here. So price was $200, and we're going to decrease that. And the quantity will be 100 people, and we're going to increase that. So over here is the price, and over here is the quantity. And it says for, we're going to take the price down by $1, so X, for each additional person. So as the price goes down for 1, the quantity goes up by 1. But keep in mind this X is number of memberships over 100. And also, from the domains aspect of this thing, from the application, we're only using X's from 100 because we can't sell less than 100. They're requiring that, and it can't go over 160. So any numbers, well, excuse me, X, that doesn't mean what X can be. X can be from 0 to 60, I'm sorry. The memberships can be from 100 to 160, but since our X is the number over 100, X has to be between 0 and 60. So that's pretty complicated, so just keep that in mind. But let's work this out. So revenue, we got a little full here. 200 times 100, I believe, is 20,000. Plus 200x minus 100x minus x squared. So clean that up. We'll have negative x squared plus 100x plus 20,000. Just right now, looking at this, we have a negative x squared, which tells you have a function that is an upside down parabola, so it should have a max somewhere in there. But let's take the derivative. So r prime of x, sorry about my microwave, is negative 2x plus 100. And we'll set that equal to 0. So we'll say 0 equals negative 2x plus 100. So solving that, you'll get x equals 50. That is members over 100. So we need 150 total memberships. To maximize revenue. So what does that say? How many memberships should be sold to try and maximize revenue? So we've answered that question now. You could take that and you could take the 50 and plug it in over here, and you would figure out that you're selling them at a price of $50 each. Because if you plug the 50 into the 200 minus x, 150 each. Big difference. Take the 50 away from the 200, you would get 150. Okay, they don't ask you that, but it's good to know. And you can multiply the two if you wanted the total revenue. Thank you.